Welcome to Algebra Online. Today we are going to be solving systems not by graphing. Nope. Not by elimination method. Nope. We are solving systems by something called substitution, which you guys are pretty good at substitution. So I'm excited to teach you about how to solve systems using the substitution method. Before we even get started though, I want you to take a look at the opener down below. Can you simplify this? I know you can. Think about the exponent rules. And so if you take a look, you'll notice that we have these pretty nice big numbers out in front. Let's go ahead and multiply them. 4 times 2 is going to give us 8. And then m to the 0 is 1. And then m to the negative 3 is a negative exponent, and we are going to write it at the bottom. We're going to draw a fraction. 8 is on the top. M to the positive 3 is in the denominator, and we have now simplified that expression. 8 over m to the positive third power. Okay, so I'd like you to pause this video and write down this problem right here, and I'm just going to go ahead and start. If you notice, both of the equations have y equals, right? If it's y equals and y equals, both of them have y equals, they're set up this way, then if y equals this part and y equals this part, don't these two equal each other? I mean, yeah, right? It's just saying that this y equals this and this y equals this, so then both of these should equal each other. And that's what we're going to write down. We're going to say that negative 6x is going to equal the negative 4x plus 2. Cool. And you can think about substitution like this. So I could say that since y equals negative 6, I can plug negative 6 in for y, right? And that's essentially what we just did. Now we are going to solve for x. So I am going to add 4x to the other side of the equation. And when I do that, I have a negative 2x equals a positive 2. And when I divide by negative 2, I have x is a negative 1. Now that's only half of an answer. Remember, the solution to our system is where these two lines intersect on a graph, right? We're not graphing this time. We're trying to do it algebraically with no graph whatsoever, which is super cool. So I need to find y. So in order to find the y coordinate, and in fact, what I'm going to do is I'm going to write my coordinate right now because I just found x. X is negative 1. So now I need to think, what can I do to solve for y? Well, I can plug in x into either equation. I could plug in x negative 1 to here or to here. It doesn't matter which equation that you use because they're both going to give you the same answer if you do the math right. So I'm going to choose a smaller one, less steps, right? So I'm going to write down y equals negative 6x, and instead of x, I'm going to write negative 1 because that's what x is. So y equals negative 6 times negative 1. Y is just going to give me a positive 6. And then these two lines, they will intersect at negative 1, 6. And we found their point of intersection without graphing. Isn't that super cool? Super cool. I absolutely love it. Okay, let's go ahead and try the next one. Now, if you feel confident, go ahead and pause this video and try it out on your own. If not, let's just go ahead and keep going. So the first thing I want you to do is I want you to notice that both of them say y equals. So if they're both y equals, they're going to equal each other. Essentially, we're going to take negative 7x plus 6 and plug it into the second equation for x. So that is going to give us negative 7x plus 6 equals a negative 10x. All right, super cool. So now I need to get all my x's on the same side of the equation. So what I'm going to do is I'm going to add 7x to the other side. And when I do that, I'm left with 6 equals a negative 3x. Keep solving for x. We're going to divide by negative 3, and that means that x is a negative 2. So right away, I always like to do this. It's just what works for me is that I like to write the x part of that answer right away in the coordinate, the point here, and then I'm going to keep going. I want to plug in that negative 2 to either equation. So I'm going to plug it into the second one. Looks like it's less steps. So I'm going to rewrite it out. Y equals negative 10x. I'm going to take this negative 2, plug it in for x. So y is going to give us a negative 10 times a negative 2. So y is a positive 20. So 20 goes here, And these two lines, they intersect at the point -2, 20. All right. Do you like substitution? I love it. I actually love it. It's one of my favorite things to do in algebra. Here's the next problem. Let's go ahead and try it out. If you notice, something's different now. Both of them do not say y equals. We only have one equation that says y equals. So I could take what y equals, it equals 2x, and I can plug it in to what the y is at on the first equation. Cool. So now what I'm going to do is I'm going to write -5x plus 3. And instead of y, I'm going to write what y is. Y is 2x. And then I'm going to keep going. Equals 2. Don't forget to continue to keep going on this whole equation right here. So now let's go ahead and solve for x. So I am going to write -5x, 3 times 2 is a plus 6x, equals 2. And these two are like terms. 6x and minus a 5x, that just gives me 1x. So x is 2. Now I'm going to take this 2 and I'm going to plug it into this equation. If you chose to plug it into this equation, we'll still get the same answer. There's just more steps here. So I'm going to rewrite y equals 2, and then instead of the x, I'm going to write 2. So y is 4. Oh man, I didn't write my little answer right here. That's okay. 2 is first because it's x. We write our coordinates x and y, and it's 2, 4, and that is the final answer. Remember, the final answer is a coordinate. It's a point. Whenever you have a system, we're looking to see where those two lines intersect on a graph, and it is 2, 4 for this problem. All right, let's try this one again. If you feel confident, press pause, try it out for a little bit, press play. It's not going to hurt anybody. It's actually going to help your learning if you do that. All right, so this one is just a tad bit different because I don't have a y equals. I have an x equals. Totally okay. X equals a -3y. So wherever I see an x equal or an x in the other equation, I can just plug it in. I can substitute. Instead of an x, I can put in a -3y. I want you to think about it like when I have a substitute teacher, right? So think about it as like x is me, right? Mrs. Wakefield. And Mrs. Wakefield now has a sub. My sub is -3y. So my sub's going to come in 4x. Substitute, just like a substitute teacher. Okay, let's keep going. So now I have -8. Instead of x, I am going to write down -3y. Now remember, they're multiplying. 8 is multiplying that x, so we need to continue with that operation and multiply -3y. But now we need to continue with the rest of the equation. Plus 2y equals 26. So let's use our rules of algebra to solve for y. So an 8 times 3, negative times negative is a positive. That's going to give us a 24y plus a 2y equals 26. And we have 26y, combined like terms on the left side of the equation, equals 26. And when we divide by 26 on each side, y is going to be 1. So y is 1. That's only half of our solution because remember our solution is a point on the graph. And this time we don't have the x first, we have the y. So I'm going to make sure that I put the 1 in the correct spot. All right, I think that this equation looks simpler to plug in the 1. So I'm going to rewrite it. -3y equals x. And I'm going to plug that 1 in for y. So -3 times 1 equals x. So x is a -3. And I have now found the solution. And it is the point -3, 1. All right, so we just got a couple more. Let's go ahead and do this example. I'm feeling pretty confident. I think you guys can do this. I think you can pause this video. I want you to trust yourself, and then when you get stuck, that's when you learn. You know, you don't learn by just listening to me and copying everything down. You won't learn that way. You won't. There's no way. The only way you're going to learn is if you try it out and then you get something wrong and then you figure it out and then your brain fires and then you start to remember and then you learn. So please pause this video. It's for you. It's for your good. Pause this video, try it out. And I'm ready. Okay, I notice there's a y equals. So I'm going to circle everything that the y equals, and I'm going to substitute it in. I'm going to plug it in for y in the second equation. So now I have 3x minus 7, and instead of y, it is 2x minus 10. And don't forget to continue the equals 37. All right, rules of algebra, let's go ahead and apply those to solve for x. So I'm going to distribute the negative 7. So I have 3x minus 14x plus 70 equals 37. Don't be alarmed by big numbers, they're fun. Okay, do we have like terms? Yes, we do. We have like terms. We have 3x and a negative 14x. That's going to give us a negative 11x plus 70 equals 37. When we subtract that 70 to the other side, we have negative 11x equals a negative 33. And therefore, we have x is a positive 3. So I'm going to draw my coordinate, and I know x is a positive 3. I'm going to choose that first equation to plug in for x. So I'm going to write down y equals 2x minus 10, and I'm going to plug in for x, the 3. So y equals 2 times 3 minus 10. Y equals 2 times 3 is 6 minus 10, and 6 minus 10 is going to give us a negative 4. And so these two lines intersect at the point negative 3, 4. Isn't it cool that we can we can find where 2 points or where 2 lines intersect the 1 point, not even by graphing, by doing it algebraically? Does anyone think this is like super cool? I know you do. Okay. So let's go ahead and try this one just because they're so much fun. Let's do it. Do you notice that the first one is written in standard form? You notice that? And both the x and the y is on the same side. So your eyeball wants to look for the equation where you just have the variable by itself. So for here, we just have y by itself. And so that's where we're going to circle everything that the y equals, and then we're going to plug that into the equation above us. So now we have 8x plus, and there's no number to multiply, it's just y, so we're going to write what y is. Y is a negative 2x minus 8. And don't forget, we need to continue that it equals 4. All right, let's go ahead and solve for x. I have like terms, which is going to give me 6x minus 8 equals 4. We're going to go ahead and add 8 to the other side. And we have 6x equals 12. Therefore, when we divide by 6, x is going to give us 2. So let's go ahead and write our coordinate point for our answer, 2. And I'm going to go ahead and plug 2 into the second equation here. And so it's negative 2x minus 8 equals y. And so I have negative 2 times 2 minus 8 equals y. Negative 2 times 2 is a negative 4. Negative 4 minus 8 is going to give me a negative 12. And therefore, these two lines intersect at the point positive 2, negative 12. Last example, guys. Last one. And here it is. If you're feeling it, try it out. If you're not feeling it, try it out anyways, right? What's the worst you can do? Get stuck and press play on the video, which is great. Please do that. That'd be awesome. If you get it right all the way, that's awesome. If you're still struggling, that's okay too, right? This is the first time you've ever seen this. And so it's okay the first time you've ever seen something to struggle, for sure. But we can practice in this for days, so no worries. All right, I'm pressing play right now. Here we go. I notice that the second equation has a variable all by itself. It's x. So I'm going to circle everything that x is, and I'm going to plug it in for x on the first equation here. Cool. All right. So I see that there's a negative out front. We have to remember that negative. It's super important. And I'm going to write a parenthesis because 3y plus 4 is going to go in for x, all of it. Plus 2y equals that negative 3. So what's going to happen now is that I do need to distribute that negative to both terms, right? It needs to go to the 3y and it needs to go to the 4. So negative 3y minus 4 plus 2y equals a negative 3. Now it looks like it gets fun. Negative 3y and a 2y, we can combine those like terms, and that's going to give me a negative y minus 4 equals a negative 3. when I add 4 to the other side, I am going to have a negative y equals a positive 1. But we can't have a negative y, right? So we need to divide by negative 1 on each side. And when we do that, our y is going to be a negative 1. So I'm going to go ahead and write negative 1 where it should be, right? In our coordinate, we always write the x first and then the y next. So I'm going to go ahead and plug in negative 1 into the second equation. And I'm going to write it out first. 3y plus 4 equals x. I'm going to take that negative 1 and plug it in. I'm going to substitute y for negative 1, or negative 1 for y, or y for negative 1. Yeah. So 3 times negative 1 plus 4 equals x. 3 times negative 1 is a negative 3, plus 4 equals x, and so x is a positive 1, and so those two lines intersect at negative 1, 1. All right, guys, I hope that you enjoyed substitution as much as I do, if not more, and I will see you guys next time. Bye.